Good morning, everybody. Can you hear me okay at the back? Good job. First of all, I'd like to welcome you all to the show. My name's Martin Passingham. I'm the product manager for Daikin air conditioning. I'll be giving some historical context to the subject of this talk, the greatest change to efficiency since the inverter. I'm going to take you through some significant developments in the air conditioning market over the past couple of decades. I'll unashamedly use Daikin as a benchmark in this process, so apologies to anybody else, apart from Daikin people. And then my colleague, Richard Green, will then bring you right up to date with the latest technology, which will be included in all future Daikin VRV air conditioning systems. There have been many changes to air conditioning technology since variable refrigerant volume technology was first introduced. The inverter compressor being one of the most notable, where for the first time there was true matching of output to meet the load requirements of a system. The greatest change to efficiency since the inverter is quite a claim. However, Daikin believed that with the new development incorporated into its latest VRV technology, we are on the cusp of another. In 1982, the first VRV system was installed in Japan. The first time this technology had been developed and marked a significant change to the way that air conditioning systems were applied to large buildings. Multiple indoor units were connected to a single outdoor unit, and the cooling heating capacity required to handle the thermal load was judged by controlling each indoor unit individually. As this new system always supplied and circulated just the required amount of refrigerant, it was named variable refrigerant volume. At this time, the full possibilities were not understood by the market. However, with the developments that I'm just about to describe, the full potential gradually became clear. In 1987, VRV technology was introduced to Europe with the VD series. This was the first time that 70 meters of pipework from indoor units to outdoor units was universally available and easy to install and commission. In 1990, inverter compressors were introduced in the G series, where true output matching of the load requirements was achieved with a correspondingly increase in efficiency. Higher static pressure supporting installations on multiple floors, up to 100-meter pipe runs, and 8 connectable indoor units. For the first VRV installation in the UK, this was in the Forum Hotel in London, now a Holiday Inn. 600 rooms and 980 fan coils in total. Each floor had 31 rooms with 4 lots of 5 horsepower VRV units per floor, all carried out in a phased introduction. Kamal Bhattacharya, who is still at Daikin, one of our training managers, was responsible for the job, and he was astonished, his words, "I was astonished," he told me, "how straightforward the commissioning was." In 1991, the first heat recovery unit where simultaneous heating and cooling was introduced for the first time. As throughout the 90s, the capacity of the system increased as well as the number of connectable indoor units. 1999 was a step change development where outdoor units were connectable for the first time, giving an outdoor capacity of 30 horsepower with up to 30 fan coils. The 90s also marked the move away from R22 as the focus on the environment and the ozone layer increased. Okay, by the end of the 90s, Daikin had many more case studies, as well as the Forum Hotel. I think this slide illustrates some of the hotels throughout Europe where VRV was installed. By the year 2000, so about 10 years since the introduction, 100,000 Daikin outdoor units have been installed across Europe, indicating that technology had been firmly established throughout the market. Throughout the next decade, the VRV systems developed even further with the introduction of 410A for the first time, systems with COPs greater than 3, mini VRV with small footprints and lower capacities for light commercial, retail and residential applications. Water-cooled VRV was introduced in 2005, where a water cooling source was available or desirable. And Daikin's VRV3 system, where efficiencies were increased alongside improved control options. Many of these technological developments allow VRV systems to be used in larger and larger buildings, taking the territory that used to be the sole preserve of chillers. Here are a number of modern examples where VRV systems have been installed in large buildings across the world. Just take you through a bit of progression here. The Colorado Tower, top left, in Stuttgart in Germany, completed in 2003. Total floor area, 7,500 meters squared. 17 VRV outdoor units and 276 indoor units. Banco Santander in Sao Paulo, Brazil, completed in 2009. 31 floors with total floor area of just over 100,000 square meters. Equipment included 62 VRV outdoor units and 1,442 indoor units. Pretty significant. And then bringing you right up to date in terms of the one in the bottom right, Shenzhen Neo building in China, completed in 2011. 62 floors, 130,000 meters square. I bet Dennis wish he had that job. With a total of 4,822 horsepower. So that was quite some job. So by the start of the next decade, further developments continue with the introduction of R22 replacement products, so customers can move to the new refrigerants while minimizing installation costs and taking advantages of improved efficiencies. The newest systems gaining 50% efficiencies level increases over the previous systems. And at this time, in Europe, Daikin had installed 400,000 outdoor units, so an increase of 300,000 outdoor units, and that's just Daikin across Europe. So you can see this technology was really beginning to take off with the developments that were taking place. So, VRV4, I'll keep that under wraps for the second, so Richard can tell you a little bit more about that. As I explained, various developments had taken place which were pretty significant over the previous 20 years. And as a summary, here are some of those important changes. Headline energy efficiencies, COP, has more than doubled, 2.2 to 4.27. Indoor-outdoor length differences have increased to 165 meters. Maximum indoor-outdoor height differences, don't want to hear, have increased from 30 to 90 meters. So as you can see, there's continuous innovation, continuous progression of this technology. And overall capacity ranges, which started out at just 10 horsepower, now are available in a range from 4 to 54 horsepower. And also the maximum outdoor unit, the capacity range for indoor units is also extended. So on here, maximum connectable indoor units, originally 6, 20 years ago, now 64 on one system. So significant advances. And as you can see in the bottom left-hand corner here, network control systems weren't really available when this technology was introduced. Now there's a host of different options which are available to control the technology. And I'd say that's one of the significant areas which has developed over time. So, reflecting on the UK market, it's continued to grow strongly. We have seen a doubling of VRV in the last decade, with a bit of a blip there for the global downturn. I think we'll blame Lehman Brothers for that one. So in terms of trends looking forwards, I'd say, looking back over the last decades, have taken us to significant growth, and looking forwards as well, BISRI are projecting growth potential over the next couple of years of 10% in terms of VRF. So still we're looking at growth going forwards. And as you can see here, just as a bit of information, the larger capacity units take up about 85% of the market. So, BISRI have also made an assessment of the important impacts of the global AC market. And for the UK right now, I'd say ERP, Energy Related Products Directive, is one of the most important drivers. And of course also the changes to F-gas, which are uppermost in our mind. So as you can see, there's lots of different factors affecting the market. But I would say those two are probably the most urgent and most important as we stand at the moment. ERP has already been implemented for systems lower than 12 kilowatt splits, but Lot 6 covering VRV systems is likely to come up by the end of 2015. The criteria have not yet been set, so we need to wait to understand how these measures will measure up against the current VRF systems which are available in the market. But you're about to see that Daikin's philosophy is that we should be leading when it comes to energy efficiency rather than being driven by legislation, which I think is a really important point. So, in terms of summary, the future is looking positive in terms of growth. It's been mentioned already by Graham in terms of coming out of an economic downturn, but we also need to consider the legislative agenda, and I think you'll hear quite a lot about that over the next couple of days. This needs to be considered, though, consistent to the direction it drives the market, so it delivers continually improving energy efficient products, although not at the expense of design and installation efficiencies. But also, I'd say, at a price where any extra costs are consistent with the added value delivered to the market. And just this slide gives you an illustration of one of the areas where Daikin has been working to deliver additional value. It's about having fully integrated HVAC systems using the principle of heat recovery. Energy is able to be transferred from areas that are not needed to where it is needed. This means that air conditioning, hot water, fresh air requirements, to name but a few, can be integrated into a single system. Now I have the pleasure of introducing my colleague Richard Green. He'll give you a glimpse of the future of VRV technology.
Okay, thank you, Martin. I passed the first test and I didn't trip up the stairs on the way up. Hello everybody, my name is Richard Green. And ever since I joined Daikin, I've been involved with direct expansion systems. And I, like most geeks, am interested in technology. And together with a passion for all forms of engineering, I'm feeling very privileged to be standing here talking about it to those for whom direct expansion systems are at least a part of what you do for a living. As you're aware, today Daikin will be launching a new system. But the way in which this system works has changed. VRV, as Martin said, stands for Variable Refrigerant Volume Systems. We control the temperature of a space by changing the amount of refrigerant that passes through a system. Well, soon, that's just to be a part of what happens. During the development, it even got to the point where we debated whether to even call this a VRV system. Well, we have three areas of our VRV systems which we've been developing for a number of years. And in this presentation, I'm just going to talk to you about one of them. The other two are very much as interesting as this one, but for the full details on that, we'd ask you to go over to our stand and maybe register for one of our seminars. Following on from what Martin Passingham has been talking about, legislation is a big driver for buildings and building services in general. And we've been listening to all of our customers, and from all the input we've received, we feed these changes into our development processes. And we work hard to exceed and meet our customer expectations. And if you're wondering how long it takes to develop, well, the development of this system started a week after we launched the last one, which was 7 years ago. Now, efficiency is a word that is used so much in our industry that it can become one of those words where the literal meaning is lost in marketing fluff and blurb. Last year, I think about every manufacturer of anything I looked at claimed to be the most efficient of everything and have class-leading technology in X, Y, and Z. And whatever product they developed, including cars and vacuum cleaners. And in the HVAC industry, we are no different. So I'd just like to take a moment just to say out loud what the Oxford English Dictionary specifies as the definition of efficiency. It is the ratio of useful work performed by a machine or in a process in relation to the total energy expended. And I think we're familiar with the description that relates to a machine. It's how much energy is used to how much is produced. But when it comes to process, there are efficiencies here too. For example, how efficient is a system to design? How flexible can it be? Can it change to meet the changing needs of a building? As well as the normal questions relating to how much energy will it use and how much carbon will it produce when it runs. And for our end customers, those who actually experience the system's comfort, it's how much will it actually cost to run? Well, this approach is what we call a 360-degree view of efficiency. And all of these performance factors are becoming more and more important. Contractors are under pressure to deliver specification compliant installations in shorter timescales. Consultants are under pressure to deliver exceptionally well-designed, efficient buildings with less resources. Building owners demand comfortable spaces for their tenants with systems that can be changed, altered and added to as demanded by the end users. And these are some of the comments we've heard from our customers, our business partners, much like you, the people sitting in this theatre. And I'd like to think we've got solutions for a lot of your requests. Believe me, we've tried. And whilst I'm not claiming we have the answer for every single question that you have, we're not quite there with a magic system that doesn't have any pipes or refrigerant just yet. But I think we're about to answer quite a few of your most common questions with the launch of the VRV IV Heat Recovery system. So Daikin's approach extends beyond the machine efficiency. For this new system, we've redesigned them from the ground up, incorporating so many new behind-the-scenes improvements that even in the launch events on our stand, we barely touched the surface. And it's this level of innovation that means that Daikin are the only company of its kind in the Forbes Top 100 list of the most innovative companies in the world. Now I'd like to take a look at the operational or machine efficiency subject for a moment. Manufacturers are required to test VRV systems to certain standards. Currently VRV is tested to the EN 14511 2013 standard. Glad I got all that out in one mouthful. So cooling is measured under a constant temperature, ambient temperature of 35 degrees outdoor temperature and 27 degrees internal temperature. This gives a tested performance of around 3 or 4. And how many times in the UK do we actually experience a temperature of 35 degrees outdoor temperature? And if it was, how many of our customers would be happy with a 27 degree indoor temperature? Well, I'd like to show you the performance curve of a generic system. At this rated condition that may exist for maybe once for every 10 minutes in Kent once a year, we have an efficiency of say 4.2. But at part load, where the system spends most of its time, the efficiencies are higher, especially if heat recovery is occurring. But as you increase your tested baseline efficiency, your part load performance decreases. So even though you look like you have a great efficiency at the tested point, in reality you have a system with a lower performance because VRV systems spend most of their time at part load. So is it really ethical now to promote higher standard efficiencies anymore? Now the ideal scenario would be a system that is better across all the points of the system. It's not based on the same technology as traditional VRV systems. In fact, something that would be similar to the advance in the efficiency that was experienced when the industry moved from on-off standard compressors to inverter compressors. Now I wonder if anybody could come up with a system like that. In 2016, when a new standard for measuring system performance arrives, it will be based on the seasonal year-round operation. You'll start seeing a much clearer picture of real seasonal system efficiencies. So today, Daikin will be revealing VRV Heat Recovery System version 4 into the market. And remember, at the beginning when I mentioned how much it had changed from a performance point of view, that we no longer just vary the amount of refrigerant going through the system, we're also varying the evaporating and condensing temperatures throughout the system. So I'm very proud to announce that we will be bringing variable refrigerant temperature to Heat Recovery VRV. In order to show you how it all works, it will take quite some time. So instead, I'm going to show you what it does. By showing you the results of a real installation, where a VRV3 system was installed and monitored, not by us, but by the customer. And then we swapped a condenser for a VRV4 system with variable refrigerant temperature. And the results were quite astonishing. What was shown was that VRV3 already had the best performance on the market, but this has now been surpassed, and not just by a little bit. When we have an 11-degree temperature difference between the outdoor temperature and the indoor temperature, the VRT effect is that the system runs at half the power input of a standard VRF system. And over a year, it is 32% more efficient. And this isn't a test that was done by us. This was done by an external end user, monitoring an old VRV III system and introducing a new VRV IV system. So VRV IV Heat Recovery brings a lot more in terms of performance. Remember when I said there was more? Well, we also have major developments that increases the flexibility of the systems in terms of installation and design to market-leading standards. And if you'd like to find out more, then please go and visit our stand. Because if you install VRV or VRF systems, then you're really going to like this. Thank you very much for taking your time to listen to us. And if you have any questions, I'd be happy to take them now. Any questions? Okay, well if that's the case, thank you very much for taking the time to sit here and listen to me. If you would like to know any more about the system, then we do have one quite big development that I think will really interest you all. Please visit our stand for more information. Thank you very much. Cheers.